Alright, so we are back with another deep dive video, and in this one what we will talk about is how to do a hybrid search and also how to do a metadata based filtering in RAG, and how we can use these techniques to get better results in RAG. So mainly this video will talk about three things. First, we will talk about what is ensemble retriever, and there we will briefly touch about what is BM25 retriever or the keyword based search. Then we will talk about maximum marginal relevance and the concept behind that MMR based retriever. And then we will combine this keyword based search along with MMR and also the vanilla RAG to do a ensemble retriever, where we will also talk about how the ensemble retriever kind of merge different documents that are coming from this three retrievers, and how it uses the reciprocal ranking concept to merge the documents, right? So then we will talk about how we can extract the keywords from user question using LLM call, which is kind of entity extraction. Then using those entity, how we can do a metadata based filtering to get better retrievals, right? And in the end, we will talk about how we can combine and simplify this concept of metadata based filtering using the concept of self-query retriever of LangChain, right? So first, let's talk about this ensemble retriever. So we have two notebooks. So the link of the notebooks will also be present in the description of this video. So you can go ahead and look into those code to understand it better. So we'll start with this ensemble retriever, where we have a document list. So then what we do is we kind of create a BM25 retriever. So in this channel, I have previously also talked about what this BM25 retriever is, but let's get a revision of this, what this concept is. So it's kind of a enhancement of the traditional TF-IDF method, which kind of considers the frequency of the words that are present in the documents, which is kind of term frequency, and the rarity of the terms across all documents to compare and to come up with the relevance score, right? So which is also a kind of an inverse document frequency. So it's just a slight modification of the TF-IDF method, which kind of uses the frequency based search, and using that we will kind of create a retriever. So you can see from langchain.retrievers, I have imported this BM25 retriever, and then I am passing this doc list to it, and also mentioning the k equals to 2, which means whenever I will try to retrieve any documents using this retriever, it will give me back two documents, right? So if I retriever dot get relevant documents and pass a query which is Apple, so you can see like two documents has been fetched, and that is like MacBook is very smooth and swift, and the other one is related to the word Apple, right? Then again, I have given another query which is like just a word which is orange, and you can see like two documents has been retrieved, so neither of them is related to orange. So if I go back to this document list, we can see like this is like there is no direct word which is orange, but there is a word which is oranges, right? So maybe that's the reason why this BM25 retriever is not able to pick up any documents which are related to orange, right? Which is, it is kind of looking the exact phrase of orange to fetch the documents from the document list, right? Then we have this concept of maximal marginal relevance, which is nothing but MMR. So this MMR kind of is a combination of like it checks the relevancy of the documents, and also how the documents are kind of diverse with respect to the previously selected documents, right? So if I just take this formula and just try to break it down for you, so we have this two terms in this equation. So one of them is like this one, which is similarity of the selected documents with a question. So if my selected document is DI and my the question is Q, then it will try to calculate the similarity between the question to this document, and it will give you a similarity score, which is this part, right? Then just imagine that we have like previously we got two documents which are like D1, D3, and now in the current while calculating the MMR, we have this new document which is D2, right? So then it will calculate this similarity between D2 to D1 and also D2 to D3, and it will see how similar are this two pair of documents, right? So it might be the case that this documents like D1, D3 and D2 have a very high overlap of the information which are being present in each of these documents, right? So we don't want to fetch another document which has a high overlap with this previous two documents, right? So that is why kind of you will see like this we have this similarity, which is a similarity between the document to the question. Then we have this term, right? And then we kind of get the maximum marginal relevance. So what we want is this term to be high and this term to be low to get a higher score of MMR, right? So if the documents if the newly selected document is kind of very similar to the previous documents, then it is not bringing any new information to the table, right? It's kind of same type of context we are retrieving. That's why we want this term to be high, and this term which kind of measures the how diverse the documents with respect to the previously selected documents. So that similarity we want to be low, right? So whenever this term is very high value and this term is kind of a low value, so for that document we will get a higher score of MMR, right? So that is kind of the intuition behind this concept of MMR. So which create a vector DB using the LangChain's chroma vector store, and after that what we will do is we will create a retriever. So you can see like db.asRetriever, and in the search type I have mentioned search type equals to MMR, and the number of documents that will be retrieved, that is equals to 2. Now if I pass the query of this just a word which is apple, so we can see like this document which is I like apples, that has been retrieved, and also this MacBook is very smooth and swift, that has also been retrieved. Maybe like it has found some similarity between the MacBook and the Apple which can be very nearer to the embedding space, so that that document has been retrieved, right? Now if I retrieve this with this keyword of orange, we can see like two document has been retrieved. One of them is like I like oranges, and another is like a irrelevant document which is like MacBook is very smooth and swift. But the first document that has been retrieved, which is much better if we are comparing with this with the BM25 retriever. So because it is kind of doing a semantic similarity between the words, so orange and oranges are very semantically similar. That's why the first document is related to the oranges, right? So this is what the concept of MMR. So then there is this vanilla rag, so which we all know and which uses the concept of similarity. So we can see like these are the outputs which will do is we will kind of combine all this retriever and we will try to create an ensemble retriever. So in this ensemble retriever, what you can see is we have given all the three retrievers. So the retriever vanilla, retriever MMR, and the BM25 retriever, and we can see like we have also given the weights of equal weights to each of these retrievers, right? And it kind of uses the concept of reciprocal ranking to merge the documents that are coming from each of these retrievers, right? Now let's try to understand what this reciprocal ranking is. So with this example, right? So for this example we have like three documents, and the three documents has a different ranking based on this three retrievers, right? So if I just go to the formula of this, so you can see like the RRF score is nothing but 1 divided by k plus RD. So this k is kind of a constant, so we can kind of for the understanding purpose we can ignore this. So straight away this formula becomes like 1 by RD, right? So this RD is nothing but the rank of the document, right? So for document 2 and this document 1 has a rank of 1 by 1, because the rank of each of this document is 1 for this case. And similarly we have this document 2, document 1, and document 3 has a rank of 1 by 3, and the last three document has a rank of 1 by 3 again, right? So if I now calculate the score for each of these documents, so if I take the example of document 1, so the document 1 belongs here, which is the rank of 1 by 1. which is nothing but 1. Then the document 1 is present also here, which is the rank is 1 by 2, and the document 1 is also present here, which has a rank of 1. So the total score for document 1 is 2.5. So similarly, we can calculate the each of these individual scores and kind of sum that. So for document 2, this is document 2 which is related to 1.2 score. Then the document 2 also present here, which is nothing but 1, and in the end the document 2 is present at the last rank, which is 1 by 3, which is, so the total score comes as 1.83. So basically it kind of uses this concept, like it will get the score of the reciprocal ranks for each of this retriever, and then it will try to combine these scores to come up with individual document scores, and based on that it will rank the documents and it will merge the documents, right? Use this ensemble retriever dot get relevant documents and pass this apple as one of the query, and we can get this two outputs, which actually three outputs, and which are much better than the previous outputs which are coming. So one of them is like I like apples, then it kind of understands that apple and MacBook is kind of similar, and also it talks about, the third document talks about the iPhone. And then if we comes with another query where the orange is given, so straight away it picks up the I like oranges, but like the third document is relevant, but the second document and the fourth document is not relevant to this question. Maybe we need to tweak this weights and give a different weights to come up with a better retriever using this ensemble retriever concept, right? So I hope you got a good understanding of how the hybrid search is kind of working using this concept of ensemble retriever, where we kind of merge three different retrievers: the vanilla retriever, then the MMR based retriever, and also the BM25 retriever, which is nothing but a keyword based retriever, right? Now let's talk about what this metadata based filtering is and how we can do it in two ways, and it's up to you how you can use it for your use case, right? So first of all, like the installations which are required, so I am using OpenAI embeddings to do the embeddings, and also the LLM as OpenAI, but you can also try out different open source embeddings or the different open source LLMs for this use case also, right? So once the installations are done, I am importing the OpenAI API key and also initializing the LLM from the chat OpenAI, where I am mentioning the temperature equals to 0. Now this document creation with metadata, so you can see like these are nothing but some movie descriptions, so which also has a page content which talks about what this movie is. Then also we have metadata, like from which year the movie is, what was the rating of that movie, and also what the genre of that movie, whether it's a science fiction or, and also we have metadata which are also talks about who is the director of that movie. So that metadata is not present across all the documents but present in the sum of the documents that are being present. So instead of creating metadata, what people also try to do is they kind of incorporate these documents in the page content, and then they create the embeddings and hope when the question is asking about something related which the metadata is, that by doing the vector search it will try to retrieve the documents as the metadata is kind of present in the page content, right? So but the better way always is to filter out your metadata and then add that metadata as information to the vector db or the chroma collection or any vector db that you are using. So once these documents are created, what I am doing is I am creating a ChromaDB collections. So this, in this collection, what we are doing is we are at first creating a client. Once we have done is we have initialized the OpenAI embedding function. If you want to use OpenAI embeddings for this ChromaDB collection, then you have to specifically mention that as one of the embedding function, else it will use a sentence transformer basic embeddings, and that it will use and create the vectors of those documents and store it in the collection. So once this initializations are done, then what I have done is I have looped through these documents and added the page content. We also need to add a unique ID, which is the document ID. So I have used this UUID Python library to get a unique ID for each of these documents. And also I have mentioned what are the metadata that are present in this each of these documents. So now your collection is ready and you can start firing queries. But before start firing queries, as users will not specifically tell like what are the metadata that we need, so user will specifically ask a particular question. So what we are doing here is we will do a kind of entity extraction. So we will try to extract what are the metadata that are present in the user query, right? So for that, what I am doing is I am creating a pydantic class which is nothing but metadata, where I am mentioning what are the metadata that are being present, and also I'm giving the description of each of these fields, and I'm making all these fields as optional, right? So what I will do is I will create a parser out of that class using this pydantic output parser, and then I will create a chat prompt template, where this template talks about like the prompt is like you only need to extract the entities and nothing else. Based on the given question, extract entities like movie, year, director, genre, and rating, right? Extract only if there is a mention of the same in the question. So what I am doing here is I am instructing LLM to only extract the metadata, and whether that metadata extraction will happen only when there is a specific mention of that in the user question. Then I am passing the user question and also the format instruction, and then I'm initializing the prompt, and then I'm creating a chain where I am passing the prompt, the LLM, and also the parser that has been initialized here, right? So once that is done, then I'm giving a question like give me details of the movie from 2020 2010 with a rating more than 8, right? So then I'm passing that question to this chain, and I'm getting this output where we can see like the metadata that are related and that are present in the ChromaDB collection. So that has been extracted. So you can see like the year is 2010 and also the rating is 8, right? So once that is being extracted, now what we can do is we can create the filter which is in line with how the filter should look like for ChromaDB collection, right? So what I am doing here is I am kind of looping each of these elements of this output, and whenever there is a rating, so I am using this greater than operator, which is nothing but GT. But for all other metadata, I am putting equal to operator, which is nothing but EQ, right? So this depends on your use case, how you want to build the final filter using this metadata, and that filter will be used whenever you are firing the query to the ChromaDB collection. So it is kind of, right? So once the filter is created, which is in line with the nomenclature and which is in line with the rule of ChromaDB collection, so you can see like this is what the filter looks like. So once that is done, now I can fire a question, right? So you can see like I'm firing a question, the question that has been initialized previously, and then I am mentioning this filter, right? And I'm mentioning this filter condition is a AND condition. So whatever the values that are present here, the year and rating, so that will be used as a AND. So what you can do is you can automate this process also, and I try to mention here is you can also add a operator in this class, which is nothing but a pydantic base model class, and then you can also ask the LLM to extract what should be the operator. Either it should be a AND or, and based on that it will do the extraction of the operator also, right? So then what I am you can see like the correct document has been fetched. So you can, if you see the document list, so this is only the document that is meeting this criteria of year equals to 2010 and rating greater than 8, right? This is the document that is being matched, and this document is kind of returned from this vector search, right? Has a manual process, like you need to extract the metadata using a LLM call, which is nothing but an entity extraction. Now LangChain has this self query retriever, which kind of simplifies this process, where at first you kind of create a vector DB, which is a LangChain's Chroma DB that we generally use. So this is different from the ChromaDB collection that we used previously. So once that is done, you will create chunks of the document and push the document to the vector DB, right? So once that is being done, you can create this. To do is you need to create this metadata field info, where for each of the attributes like genre, year, you will give a description and also the data type of each of these fields. So that is the info that you need to create here. So once that is being created, what you need to do is create a structured query constructor with LLM. So this will create a query which will have the metadata info and all the manual steps that we have been used in the previous step, where we have kind of extracted the metadata using LLM call, then created the filter which is in line with the format of ChromaDB. That will be taken care using this. What you need to do is you will create a prompt. You need to pass this metadata field info and also the document content description, which is created here, which you can see here, which talks about like brief summary of a movie. So all this info you need to pass in this get query constructor prompt, which will give you back the prompt, and then you will have this output parser, which is nothing but a structured output parser. And then what we will do is we will create a chain, which is nothing but query constructor, where we will pass this prompt, the previously initialized LLM, and also the output parser. So now if I just test it out how this query constructor will work. So if you need to pass the question to this, and what you can do is query constructor dot invoke, and then you pass the question, and you can see like it is understanding what are the filters that are present, and in that way it will create all these values which are related for the query, right? You can see like the operator is fetched as AND, which we manually provided in the previous step. Then it talks about what are the arguments that has been extracted. So you can see like the attribute year is present, and also it talks about its equality operator, and the value is 2010, right? So then it will pick up this rating info as an attribute, and it will use the operator as greater than, and the value is 8.0, right? So all these steps which we did in previously in a manual way, so this will enable you to do it in a more structured way with LLM call. But yeah, this again involves LLM call, but lesser operations you need to do with, if you compare with the previous steps where we did everything manually, right? So once that is done, then what you can do is you can translate this query according to the vector DB that you are using. So for that, what we will use is this Chroma translator. So using that Chroma translator, we will use this self query retriever. In this self query retriever, we will pass this query constructor, the vector DB, and also this chroma translator, which we have initialized in this phase, right? So once that is done, now we have the retriever. So using this retriever, we will fire the question, and all the metadata based filtering and the filter creation, then the filtering by reducing the search space, it will like reduce the search space, then it will do the semantic search. All that will happen automatically using this, right? Now you can pass the same question which we have used, and we can get the similar content that has been retrieved from this using this retriever, right? So we can see not only the document is retrieved, it's also talking about the metadata that has been fetched, right? So similarly, we can pass another query which is like what's a movie after 1990 and before 2005 that's all about toys and preferably animated, right? So then it does the operations, and it picks up what are the metadata, like the genre is animated and the year is 1995, right? And then it gives you the content of this retrieved page content, right? So I hope you got a good understanding of how you can get better results if you incorporate more metadata and use this concept to get a metadata based filtering, which will, at first it will reduce the search space, then it will do the semantic search and give you better outputs if you are using this self query retriever or the metadata based filtering, right? So with this I will end this video where we talked about different hybrid searches that you can implement while doing RAG, and which will give you better results, right? So with this I will end this video. Thank you. See you in the next video.